So now see, this is the flow diagram. Flow diagram is very important. So see, this is in this flow diagram we have the window size is 7, 0 to 6. Okay, so this is the SM. At initially this is the SM and this is SN. This frame need to send at first, and when this frame is sending, frame 0 is sending, the now SN will be indicate the next frame. Okay, so this is the SF and the next frame is this SN. So the request is passing, the frame 0 is passed here, frame 0 is passing to the receiver and receiver is passing the acknowledgement. So acknowledgement is received by the receiver, this is fine. So now see, this Rn is increment by 1. So now Rn expecting frame 1. Okay, so frame 1 is passing, the next frame 1 is passing here. So it is received by the receiver and Rn now is 2. But this acknowledgement is corrupted, this acknowledgement is lost here. So if this acknowledgement is lost here, then what to do? Then frame 2, the timer is not out, so it will send the next value, next frame value. So it will send 1 and 2, next frame is 2, so it will send the second frame, frame 2, and frame 2, acknowledgement of frame 2 is received. Say acknowledgement 3. Okay, next, that means receiver is expecting third frame. So third frame is passing to the receiver and receiver is received the frame. Okay, so now when the one acknowledgement, this acknowledgement 2 is not received by the sender, but 3 and 4 is also received, and 2, 3, 4, 1, 2, 3, 4, all this frame is received by, this is arrived to the receiver, receiver received it, but the one single frame's acknowledgement is not received by the sender. Then what to do? So this is the general case. So if this type of situations is happening, then in case of go back in ARQ, what we can do? The name is go back in ARQ. That means if there is any error is occurred, because sender is not received the acknowledgement too, so sender don't know that frame 1 is actually received or not. So sender don't have any idea about that. So sender will do what? Sender will send all those frames from frame 1, frame 1, frame 2, frame 3, all these values sender will send in this protocol, in go back and click in ARQ. That means you can go back to the nth number of frame which is actually corrupted. So you can go back there and you should resend all those frames. That's why this name is go back in ARQ. And this is also very means time consuming. It will take means unnecessary time, because already those frames are received, but still according to the protocol you need to resend all this value. So see this diagram here, frame 0 is acknowledgement is received, frame 1 acknowledgement, frame 1 is lost. Okay, here frame 1 acknowledgement, this is acknowledgement, lost of acknowledgement, but here in these situations the frame 1 is lost. Frame 1 is lost, this is passing, frame 1 is lost, and then frame 2, frame 3, all these values is actually arrived. But see, what is the thing? Here Rn is equal to 0 and that is expecting, so frame 0 is there and acknowledgement is passing. So now Rn is expecting what? Rn is expecting 1. Okay, first frame, but see this frame 1 is lost, but there is no message to the sender that this frame is lost. Sender don't know about that. So sender is sending frame 2 because sender is waiting for the timeout. If time is out and sender did not get any acknowledgement from the receiver, then only sender understand that yes, there is an error. Okay, but here you can see that frame 1 is lost. So now receiver is expecting frame 1. So if sender is sending frame 2, then it will be no action. This frame is not accepted by the receiver. Again it's sending frame 3, but this is arrived but no action, it will not received. So what to do? Then when the timer is out, then sender send all this frame from where it is corrupted. That is, it can send frame 1, so frame 1 will be arrived and accepted, then Rn is equal to 2. Next it is resend frame 2, so frame 2, that means this value is resent and this is accepted, frame 2 is accepted. Okay, and the next frame it is wants to receive frame 3, so frame 3 is resent and this is accepted. So that means here what is happening, that is, if there is a single frame lost, you have to send all those frames from that corrupted frame, because all those frames you are sending but that is not received by the receiver. So that's why this is called go back in ARQ. So this stop and wait ARQ is a special case of go back in ARQ in which the size of the send window is 1. Okay. Receiver window is 1. Okay. So this is the significance of go back in ARQ, and sometimes these questions you can face that if the situations is happening these things, and from suppose there is frame 2 is corrupted, then how many frames the sender needs to send again. This type of things can be there, this type of questions can be there. So this is the thing with stop and wait ARQ. You have to remember it. Stop and wait ARQ is a special case of go back in ARQ in which the size of the send window is 1, sender window size is 1. So now this is the, so here is a problem of go back in ARQ, that is, if a single frame is corrupted, you need to send, the sender need to send all those frames from that corrupted frame. So the time is here time factor is there, that is we need more time to do that. So time factor is there. Now send window for, so we have to go for selective repeat ARQ. This is the algorithm, that is selective repeat ARQ. Selective repeat ARQ means what? Selective means you have to select that frame, what is corrupted. Okay, select that frame what is corrupted, that is selective, and repeat ARQ, that frame you need to send to the receiver only. Okay, not the whole frames. So here you can see the SF equal to this, and the size of the window is 2 to the power m minus 1, 2 to the power m minus 1. Okay, here the size of window is a little bit different. Here the size of the sender and the receiver window at most here the selective repeat ARQ, the size of the sender and receiver window must be at most 1/2 of 2 to the power m. Okay, it must be 1/2 of 2 to the power m. So this is window size is 2 to the power minus 2 to the power m minus 1, and this is 2 to the power m minus 1. The size is greater than 2 to the power m minus 1. Here size is equal to 2 to the power m minus 1, and here size is greater than 2 to the power m minus 1. Okay, so see what is happening here. So if this size is 2 to the power m minus 1, then what is happening? That is frame 0 is passing. Frame 0 is passing. The sender send this frame 0 to the receiver, and the acknowledgement is lost. Again frame 1 is passing here. So window size is what? That is 0 and 1. This small window. Okay. If m is equal to 2, then 2 to the power 2 minus 1, 2 to the power 2 minus 1, that is the size of window is 2. Okay, here and here is greater than 2. So in this case it is getting 3, 0, 1, 2. This 3 values are inside the window, and here 2 values. So 0, 1, if frame 0 is passing, so to the receiver, so receiver received frame 0, but acknowledgement is lost. Here frame 1 is passing, but acknowledgement is lost. Here also. So receiver, what the receiver will do, this timer is out, and sender is sending frame 0 again. Okay, so this 0 is received, this 1 is also received, but again, so now receiver is expecting what? Receiver is expecting 2, frame 2. So in that case, if frame 0 is passing from the sender, then it will be discarded. So it is correctly discarded. That means duplicate frame is not accepted by the receiver. But if the frame size is 3, in that case this duplicate frame, so frame 0, 1, 2 both are received. Okay, so now, and frame 3 also it can be received, but after that, after frame 3 it wants to receive frame 0. Okay, but this frame 0 is the duplicate frames whose acknowledgement is not received by the receiver. So again, when sender send all these frames 0, 1, 2, 2, as because sender is not getting any acknowledgement, so sender thought that this frames is not received by the receiver, so sender will send all these values. Then what will happen? Erroneously all these values will be accepted by the receiver. Okay, so if window size is greater than 2 to the power n, then duplicate frames will be accepted by the receiver. So we need to put our values as 2 to the power m minus 1. It should be, the size should be 2 to the power m minus 1. Okay, so for selective repeat ARQ, the size should be 2 to the power m minus 1. Okay, and for go back in ARQ, it should be less than 2 to the power m. If there is also a problem, if it is equal to 2 to the power m, then we will get the receiver will erroneously accept some values, some frames. Okay, so window size is very important. You have to remember that what is the window size of sender and receiver of a particular algorithm. So this is a sender side selective repeat algorithm. Okay, so in the next class we will discuss about that. Okay, because it will take much more time. So today you have to remember about how the selective, that is how go back in ARQ is working, and what is the problem of go back in ARQ, and what is the solutions of that problem. Go back in ARQ has the problem that if a single frame is lost, then all the frames need to resend to the receiver. Okay, from where there is corruptions is occurring, you have to sender is send all these values, so it will take much more time also. Unnecessary time delay is occurring there. So that's why we should go for selective repeat ARQ. Okay.